Hello children, we are going to start with problem set 5. Choose the correct alternative answer for each of the following questions. Which number cannot represent a probability? 2 by 3, it will be less than 1. 1.5. 15% means 15 upon 100 is 0.15. D is 0.7. So option will be B. You choose the correct alternative. Please write the option number and the answer in board exam. Next, a die is rolled. What is the possibility that the number appearing on the upper face is less than 3? Less than 3 will be 1, 2. So, 2 numbers will be there out of 6. So, 2 by 6 is 1 by 3. Option is again B. What is the probability of the event that a number chosen from 1 to 100 is a prime number? How many numbers are there prime numbers? 25. N of S is 100. So it will be 25 upon 100 is 1 by 4. Option is C. Here explanation is given for your ready reference. There are 40 cards in a bag. Each bears a number from 1 to 40. One card is drawn at random. What is the possibility that the card bears a number which is in multiple of 5? So here 40 cards are there. So such numbers 5, 10, 15, 20, 25, 30, 35, 40. So 8 numbers will be there. So 8 upon 40 equals to 1 by 5. Option will be A. If n of A is 2, P of A is 1 by 5, then n of S is what? N of S will be n of A upon P of A. So it will be 10. Question number 2. Basketball players John, Wasim, Akash were practicing the ball drop in the basket. The probabilities of success for John, Wasim and Akash are 4 by 5, 0.83 and 58% respectively. Who had the greatest possibility of success? Here the probability that the ball dropped in the basket by John is 4 by 5. Convert it into decimal. You will get 0.80. The probability that the ball dropped by the basket by Wasim equals to 0.83. The probability that the ball is dropped in the basket by Akash is 58%. So 58 upon 100 it will be 0.58. Here you see from the decimal points calculation 0.83 is greater than 0.80 is greater than 0.58. Therefore, Wasim has the greatest probability of success. Next question 3. In a hockey team, there are 6 defenders, 4 offenders and 1 goalie. Out of this, one player is to be selected randomly as a captain. Find the probability of the selection that the goalie will be selected. A defender will be selected. The total number of players in the hockey team are 6 plus 4 plus 1 equals to 11. So n of S, sample space, will be 11. Let A be the event that the captain selected will be a goalie. There is only one goalie in the hockey team. Therefore, n of A equals to 1. So P of A equals to n of A upon n of S. So probability of selecting goalie will be 1 by 11. Let B be the event that the captain selected will be a defender. There are 6 defenders in the hockey team. Therefore, n of B will be 6. So P of B equals to n of B upon n of S equals to 6 by 11 equals to P of B will be 6 by 11 and P of A will be 1 by 11. Question number 4. Joseph kept 26 cards in a cap bearing one English alphabet on each card. One card is drawn at random. What is the probability that the card drawn is the vowel card? Vowel you know very well. A, E, I, O, U are vowels. So each card bears an English alphabet. A to Z numbers are 1 to 26. So N of S equals to 26. Let A be the event that the card drawn is a vowel card. There are 5 vowels in English alphabets. So A is the set of A, E, I, O, U. Therefore, N of A equals to 5. So P of A equals to N of A upon N of S equals to 5 by 26. Therefore, the probability that the card drawn is a vowel card is 5 by 26. Next example, question 5. A balloon vendor has 2 red, 3 blue and 4 green balloons. He wants to choose one of them at random to give it to Pranali. What is the probability of the event that Pranali gets? A red balloon, a blue balloon, a green balloon. So let 2 red balloons be R1 and R2, 3 blue balloons be B1, B2 and B3, and 4 green balloons be G1, G2, G3 and G4. Therefore, sample space will be of all these terms. So N of S equals to 9. Let A be the event that Pranali gets a red balloon. Set of A will be R1, R2 only. So N of A equals to 2. So probability of A will be 2 by 9. Therefore, the probability that the Pranali gets a red balloon is 2 by 9. Let B be the event that the Pranali gets a blue balloon. Therefore, set of B equals to B1, B2, B3. Therefore, N of B equals to 3. Probability of B will be 3 by 9 equals to 1 by 3. Therefore, the probability that Pranali gets a blue balloon is 1 by 3. Let C be the event that the Pranali gets a green balloon. C equals to G1, G2, G3, G4. So N of C equals to 4. Therefore, probability of C equals to 4 by 9. Therefore, the probability that Pranali gets a green balloon is 4 by 9. Next question. 6. A box contains 5 red, 8 blue and 3 green pens. Rutuja wants to pick a pen at random. What is the probability that the pen is blue? So let 5 red pens be R1, R2, R3, R4 and R5. 8 blue pens be B1, B2, B3, B4, B5, B6, B7, B8 and 3 green pens be G1, G2, G3. Therefore, sample space will be of all these colors. S equals to R1 to R5, B1 to B8 and G1 to G3. Total number of N of S equals to 16. Let A be the event that Rutuja picks a blue pen will be set of A from B1 to B8. So N of A equals to 8. Probability of A set will be 8 by 16, that is 1 is to 2. Therefore, the probability that Rutuja picks up a blue pen is 1 by 2. Next problem, 6 phases of a die are shown below. Here numbers are not given 1, 2, 3, 4. Here A, B, C, D, E and sixth one is again A. If the die is rolled once, find the probability of A appears on the upper face, D appears on the upper face. Sample space S equals to A, B, C, D, E and A. So N of S equals to 6. Let R be an event that A appears on the upper face. So R event will be such that A can appear twice, 1 and 2. So N of R equals to 2. Therefore, probability of R will be 2 by 6 equals to 1 by 3. Let Q be the event that D appears on the upper face. Therefore, total number of faces having D on it equals to 1. That is, the set of Q equals to D, only 1. So n of q equals to 1. Therefore, probability of q equals to 1 by 6. That is P of R equals to 1 by 3. P of Q equals to 1 by 6. Next question. A box contains 30 tickets bearing only one number from 1 to 30 on each. If one ticket is drawn at random, find the probability of an event that the ticket drawn bears an odd number, a complete square number. Second event. So sample space will be S equals to numbers from 1 to 30. So n of S equals to 30. First event, let A be the event that the ticket drawn bears an odd number. You know odd numbers. So set of A will be 1, 3, 5, 7, so on up to 29. Therefore, n of A equals to 15. Probability A will be 15 upon 30. Therefore, this equals to 1 by 2. Let B be the event that the ticket drawn bears a complete square number. Square number. Set of B will be 1 square is 1. So 1, 2 square 4, 3 square 9, 4 square 6, 5 square 25. 6 square will be 36, which is not in the sample space. So we don't consider further. So 1, 2, 3, 4, 5. So n of B equals to 5. Probability of B will be 5 by 30 equals to 1 by 6. So in this problem, probability of event A will be 1 by 2 and that of probability of event B will be 1 by 6. Next problem. Length and breadth of a rectangular garden are 77 meter and 50 meter. There is a circular lake in the garden having diameter 14 meter. Due to a wind, a towel from a terrace on a nearby building fell into the garden. Then find the probability of the event that it will fall in the lake. Now here you see diagram. This rectangular is 77 meter by 50 meter and 14 meter is the diameter of this circle. So radius will be half of it, 7 meter. Now solution, area of the rectangular garden is length into breadth, 77 into 50 equals to 3850 square meter. Radius of the lake will be 14 upon 2. Diameter was given. So 14 upon 2 equals to 7 meter. Area of circular lake, pi r square. Area of circle you know, pi r square. 22 upon 7 into 7 into 7. So area of circular lake equals to 154 square meter. Probability that the towel fell in the lake will be area of the lake divided by area of the garden rectangle. That is 154 upon 3850. If you simplify it, you will get 1 upon 25. Therefore, the probability of the event that the towel fell, it must be fell here, in the lake is 1 by 25. Next question. In a game of chance, a spinning arrow comes to rest at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. All these are equally likely outcomes. Find the probability that it will rest at 4 events are asked, at 8, an odd number, a number greater than 2, a number less than 9. So here diagram is explained. So here you see the solution, sample space is S, 1 to 8. Therefore, n of S equals to 8. Let A be the event that the spinning arrow comes to rest at 8. So A event will be having only one element, that is 8. Therefore, n of A equals to 1. Probability of getting A set will be 1 by 8. Let B be the event that the spinning arrow comes to rest at an odd number. Now set of B will be odd number 1, 3, 5, 7 from the given sample space. So n of B equals to 4. So probability of B will be 4 upon 8, 1 by 2. Let C be the event that the spinning arrow comes to rest at a number greater than 2. So 1 and 2 will not be considered. C set will be 3, 4, 5, 6, 7, 8. So n of C equals to 6. So probability of C will be 6 by 8, 3 by 4. Let D be the event that the spinning arrow comes to rest at a number less than 9. Less than 9 means all 1 to 8 numbers will be included in this event. So n of D will be 8. N of D equals to 8 upon n of S 8. Therefore, P of D equals to 1. So here probability will be 100% that from 1 to 8 number any number will come. 100% chance of getting one number which is less than 9. Next question. There are 6 cards in a box, each bearing a number from 0 to 5. Find the probability of each of the following events: that a card drawn shows a natural number, a number less than 1, a whole number, a number greater than 5. 4 events are asked. Sample space S will be 0 to 5 numbers. So total n of S will be 6. Let A be the event that the card drawn shows a natural number A 1 to 5. Therefore n of A equals to 5. Probability of A event will be 5 by 6. Let B be the event that the card drawn shows a number less than 1. Less than 1 is only 0. So B set will be 0 element. Therefore n of B equals to 1. One element is there. So n of B will be 1. So probability here will be 1 by 6. Let C be the event that the card drawn shows a whole number. Therefore C event will be 0, 1, 2, 3, 4, 5. As you know, whole number starts from 0. Therefore n of C equals to 6. So probability C equals to 6 by 6 equals to 100%. Let D be the event that the card drawn shows a number greater than 5. Here the greatest number is 5. Therefore, event D is an impossible event. Therefore, D equals to null set. So, n of D equals to 0. So, probability of D will be 0 upon 6. That is 0. Next problem. A bag contains 3 red, 3 white and 3 green balls. One ball is taken out of the bag at random. What is the probability that the ball drawn is? The 3 events are given: red, not red, either red or white. Solution: let the 3 red balls be R1, R2, R3, 3 white balls be W1, W2, W3 and 3 green balls be G1, G2, G3. Therefore, sample space S equals to R1, R2, R3, W1, W2, W3, G1, G2, G3. Therefore, n of S equals to 9. Event A. Let the A be the event that the ball drawn is red. So, A event equals to R1, R2, R3. So, n of A equals to 3. Therefore, probability A will be 3 by 9 equals to 1 by 3. Next, let B be the event that the ball drawn is not red. So, it will be either white or green. So, B set will be W1, W2, W3, G1, G2, G3. Therefore, n of B equals to 6. So, probability B will be 6 by 9, that is 2 by 3. Third event, let C be the event that the ball drawn is red or white. So, set of C will be R1, R2, R3, W1, W2, W3. So, n of C equals to 6. So, probability will be 6 by 9 equals to 2 by 3. Next problem. Each card bears one letter from the word mathematics. The cards are placed on a table upside down. Find the probability that a card drawn bears the letter M. Now here the sample space where you are writing, write the spelling of mathematics with after each alphabet give one comma. Very simple thing. So here M-A-T-H-E-M-A-T-I-C-S. How many alphabets are here given? N of S equals to 11. Let A be the event that the card drawn bears the letter M. So M is here also, M is here also. So A equals to M, M. So N of A will be 2. So probability of getting M will be P of A equals to 2 by 11. Next, out of 200 students from a school, 135 like kabaddi, the remaining students do not like the game. Out of 200 students from a school, 135 like kabaddi. So liking kabaddi is 135 and the remaining students are 65. They do not like the game. Yes, 65 number is not given. If one student is selected at random from all the students, find the probability that the selected student does not like kabaddi. A number of students in the school is 200, so N of S will be 200. Number of students who like kabaddi 135. Therefore, number of students who do not like kabaddi will be 200 minus 135 equals to 65. Let A be the event that the student selected does not like kabaddi. So N of A will be 65. So probability of A will be 65 upon 200. If you simplify, it will be 13 upon 40. The probability that the student selected does not like kabaddi is 13 by 40. Next, a two-digit number is to be found from the digits 0, 1, 2, 3, 4. Repetition of the digits is allowed. Read the problem carefully. Find the probability that the number so formed is a prime number, multiple of 4, multiple of 11. So your sample space will be 10, 11. Repetition is allowed. 12, 13, 14. Then 20, 21, 22, 23, 24. 30, 31, 32, 33, 34. 40, 41, 42, 43, 44. So here 5 numbers in each row. So 4 rows are here. So N of S equals to 20. Let A be the event that the number so formed is a prime numbers. So set of prime numbers A equals to 11, 13, 23, 31, 41, 43. So total numbers are N of A equals to 6. So probability A will be 6 by 20. Simplify it, you will get 3 by 10. Let B be the event that the number so formed is a multiple of 4. Therefore, B equals to set of B, that is equals to 12, 20, 24, 32, 40, 44. So how many numbers are there? 6. So N of B will be 6. So probability B will be 6 by 20. Simplify it, it will be 3 by 10. Let C be the event that the number so formed is a multiple of 11. So set C equals to 11, 22, 33, 44. Therefore, N of C equals to 4. So probability of C will be 4 upon 20 equals to 1 by 5. Next question, the faces of a die bear numbers 0, 1, 2, 3, 4, 5. If the die is rolled twice, then find the probability that the product of digits on the upper face is 0. Solution, sample space S. This type of problem we have already seen in the exercise, yet we see. So first we will take 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Then 1, 0, 1, 1, 1, 2, 1, 3. Then related to 2, 1, 2, 0, 2, 1, 2, 2, 2, 3, so on up to 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Therefore, N of S equals to 36. When two dice are rolled, then we get 36 number of sample space. Let A be the event that the product of the digits on the upper face is 0. Product. So A event will be 0 in 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. So N of A will be 11. So probability A will be 11 upon 36. Next problem, do the following activity. the number of students in your class. Now I have not taken any class, I have taken a standard class of 40 students. So n of s equals to 40. Number of students from your class wearing spectacles, n of a 6. Probability of a randomly selected student wearing spectacles will be 6 upon 40, n of a upon n of s. Simplify it, it will be 3 by 20. Probability of randomly selected student not wearing spectacles. So out of 40 minus 6, it will be 34 upon 40. So simplify it, it will be 17 by 20. Very simple example. Next activity given on the same page is there. Let us suppose the sample space be 1 to 10. Event A getting an even number. So 2, 4, 6, 8, 10. So n of a will be 5. So probability of finding a will be 5 by 10. Simplify it, you will get 1 by 2. This much is sufficient for this. In the next video, we are going to start with the new chapter. Till then, goodbye, take care. Thank you.